Bismillahir Rahmanir Rahim. Still, we are discussing the inequalities. In the part that we have discussed before, we gave some examples about the linear inequalities. Then we discussed the compound inequalities, and also we saw some examples involving absolute value inequalities. In this part, we are going to speak about the polynomial inequalities, where the one side is a polynomial and it's greater than constant or greater than 0. To solve a polynomial inequality, we are using something called the critical value method. And the critical value method is this one, solve polynomial inequality by critical value method. We have 3 steps. Step number 1, if the inequality is not written in a way that the other side is equal to 0, we have to write the inequality so that one side of the inequality is a non-zero polynomial and the other side is equal to 0. So we have to keep one side equal to 0 and the polynomial is in the other side. Second step, we need to find the real zeros of the polynomial. Find the real zeros. These real zeros are the critical values. We call these values are critical values of the original inequality. So we need to find the real zeros of the polynomial. Whatever is the method to find the zero, these will be the critical values of the inequality. In the third step, we use test value to determine which of the consecutive interval formed by the critical values are to be included in the solution set. So in the third step, we are going to pick testing values so that we will decide whether the inequality is positive over that interval or negative. To explain this in more detail, let's have some examples. I want to use the critical value method to solve each polynomial inequality, and we need to write the solution in the interval notation. In our first example, we have x squared plus 7x greater than 0. So we can see left-hand side is polynomial, the other side is 0. So first step is okay. The other side is equal to 0. So x squared plus 7x is greater than 0. Now, I need to find the critical values. In this step, we need to find the critical value, CV, I mean the critical values of the polynomial x squared plus 7x equal to 0. I need to find the zeros of this polynomial or the critical value of the inequality. I have x squared plus 7x equal to 0. To find the zeros, I will take x as a common factor, and I will have x times x plus 7 equal to 0, which means that either x equal to 0 or x equal to minus 7. So x equal to 0, x equal to minus 7, these are the critical values. 0 and minus 7. So this is step number 1. Step number 2. Check the sign of the inequality. Check the sign of the inequality. I have 0, this is one critical value, and I have 7 or minus 7. So this is minus 7 and 0. It is minus 7 and 0. We have to keep the order. Minus 7 and 0, these are the critical values of the inequality. My inequality is x squared plus 7x. Now I'm going to pick a number that less than minus 7. I will choose minus 8. This will be my testing value. I will use this one to test the sign of the inequality. Now I pick the minus 8. I'm going to replace x by minus 8. So it is minus 8 squared plus 7 times minus 8. That will give me 64 minus 56 equal to 8. All what I need now is the sign of the number. It is positive. So the sign is positive. I need the sign of the output of the value, which is plus 8. Between minus 7 and 0, I will pick another testing value. Let's say I'm going to choose minus 1. Again, I'm going to evaluate now the inequality or the polynomial at this number. So minus 1 square plus 7 times minus 1 equal to 1 minus 7 is minus 6. Again, all what I need the sign. So between minus 7 and 0, it is negative. Greater than 0, I will choose 2. So it is replace x or substitute x by 2. It is 2 square plus 7 times 2 equal to 4 plus 14, which is equal to 18. It is positive, so the sign is positive. Now I have positive, negative, and positive. I have to choose either the positive or the negative. If we go back to the inequality, the sign of the inequality is greater than 0. Greater than 0 means positive. So in this case, the solution will be represented by the positive sign. It is this one. I will choose the positive sign. Then I will say, now the solution set for this inequality, it is the positive, which is given by the interval. This interval is from minus infinity to minus 7 open, because I have greater than without equal. So it is open interval. Again, minus 7 is not closed. It is open because I have only greater than. And the other one, open from 0 to infinity. We are using the critical values, minus 7 and 0, not the distinct values, critical values. So I have two intervals from minus infinity to minus 7 and 0 to infinity, and we must have union between them. That means the left interval and the right one, or from minus infinity to minus 7, union 0 to infinity. This will give me the solution set for the given inequality, polynomial inequality. Let's have another example. X squared plus 5, x plus 6 less than 0. So the first one is okay, less than 0. Don't need to do anything. So in the first step, step number 1, is find the critical value. So I have x squared plus 5x plus 6 equal to 0. I need to find the zeros for this polynomial, or the real zeros. These are the critical values. This can be done by factoring, or by the completing the square, or by the quadratic formula. Any one of them will be okay. So if I do it by factoring, it is x plus 2 and x plus 3 equal to 0. So I'll have either x equal to minus 2 or x equal to minus 3. These will be the critical values, minus 2 and minus 3. In the second step, we need to take the sign. Of the inequality. So I have to take the sign minus 3 and minus 2. My polynomial is x squared plus 5x plus 6. So I have to check or to choose distinct values. I will choose minus 4. That is less than minus 3. And between minus 3 and minus 2 is minus 2.5 or minus 5 over 2. Greater than minus 2, I can choose 0. This will be the distinct values. Now replace or substitute x by minus 4, the first one. I'll have minus 4 square plus 5 times minus 4 plus 6. This will give me 16 minus 20 plus 6, that will be plus 2. So it is positive. In this interval, it is positive. Between minus 3 and minus 2, let's substitute or replace x by minus 2.5. Square plus 5 times minus 2.5 plus 6 is equal to minus 6.25. And this will be minus 12.5 and plus 6. We will have minus 0.25. So it is negative. For the third one, 0, replace x by 0. I will get only 6, that will be positive. So it is positive, negative, and positive. Now, the sign of the inequality is less than 0. It means we are looking for something less than 0, which is negative. So in this case, the solution set is the negative, which means the solution set using an interval notation will be between minus 3 and minus 2. Again, we are using the critical values, and it is open interval because I have less than. There is no equality. So I must have open interval. It is between minus 3 and minus 2. One more example. I have x squared minus 3x greater than or equal to 24. We can see that the right-hand side is not equal to 0. So I have to move it to the left-hand side. So I have to write the inequality in this form. X squared minus 3x minus 28 greater than or equal to 0. Now the right-hand side is 0. So I can find now the critical values. Step number 1. Critical values of x squared minus 3x minus 28 equal to 0. This can be done by factoring, which is x minus 7 and x plus 4 equal to 0. So either x will be equal to 7 or x equal to minus 4. So these are the critical values, minus 4 and 7. So the second step, step number 2, we need to take the sign. I have minus 4 and 7. And the inequality I have is x squared minus 3x minus 28. So to pick the testing value less than minus 4, in this interval I will choose minus 5. I need number less than minus 4. It is minus 5. Between minus 4 and 7, I'm going to choose 0. Greater than 7, I will choose 8. You can choose any number greater than 7, 8, 9, 10, whatever. Any number greater than 7 or a number between minus 4 and 7, a number less than minus 4. I have 3 intervals. I will choose one testing value for each interval. In the first one, we replace x by minus 5. It is minus 5 squared minus 3 times minus 5 minus 28. This will give me 25 plus 15 minus 28, which is equal to 12 or plus 12. It is positive. Between minus 4 and 7, which was 0. So replace x by 0, I will have minus 28. That is negative number, negative value. Greater than 7, which was 8. For this one, it is 8 squared minus 3 times 8 minus 28. That will be 64. minus 24 minus 28, which is equal to plus 12. Again, this is positive. Now, which one should I choose? The positive or the negative? If we go back to the inequality, it is greater than 0. Means we are looking for the positive. Greater than 0 means positive. So the solution set will be these two intervals. So we can say the solution set is equal to, from the first interval, this one. So the solution set in this case will be the two interval minus infinity to minus 4 union close interval 7 to infinity. So this will be the solution set for this inequality. One more example. Minus 9 minus 9 greater than 0. Again, in the first step, is find the critical value of the, or the critical values of the inequality x 3 plus x to power 2 minus 9 x minus 9 equal to 0. All what I need to find the zeros of this polynomial. And this can be done by grouping, because I have 4 terms. So I can take the first 2 terms, I say x to power 3 plus x squared in one group, plus minus 9x minus 9 as a bracket. Take the common factor for the first one, which is x squared. Common factor, then I will have x plus 1. And take minus 9 as a common factor from the second bracket, will be x plus 1 equal to 0. Now we have x plus 1 is common factor. I have x plus 1 as a common factor, then I will have the remaining will be x squared minus 9 equal to 0. But also this one can be factored more. There's difference between two squares. So it is x plus 1 times x minus 3 and x plus 3 equal to 0. And the first one will give me x equal to minus 1, or x equal to 3, or x equal to minus 3. These are the critical values, minus 1, 3, and minus 3. So we are done from the first step. Second step, check the sign. Of the inequality, or of the polynomial. I have minus 3, we have minus 1, and we have 3. These are the critical value, and we have to put them in the normal order, from the smaller, or from the smallest to the largest. And I will choose testing values. Less than minus 3, I will choose minus 4. Between minus 3 and minus 1, I will choose minus 2. Between minus 1 and 3, we can choose 0. Greater than 3, we can choose 4. My polynomial again is x to the power 3 plus x squared minus 9x minus 9. So replace x by minus 4. That will be minus 4 to the power 3 plus minus 4 to the power 2 minus 9 times minus 4 minus 9. This is equal to minus 64 plus 16 plus 36 minus 9. And you can see this is negative. It will be a negative number. It is minus 73. It is minus actually 21. It is negative. The sign is negative. Now for the second testing value, which is minus 2, replace x by minus 2. Minus 2 to power 3 plus minus 2 square minus 9 times minus 2 minus 9. This will be minus 8 plus 4 plus 18 minus 9. It is 22 minus 17 is equal to plus 5. So this is positive. For the third one, when it is 0, this will be 0, 0, 0. The remainder is minus 9, which is negative. If it is 4, I will have, again, replaced by 4, it is 4 to power 3 plus 4 to power 2 minus 9 multiplied by 4 minus 9. That will be 64 plus 16 minus 36 minus 9. This is 80 minus 45 is equal to 40 or 35. This is positive. So if I choose 4, I would have positive. Now, which one should I choose, the positive or the negative? I have to check the sign is positive. So the solution set will be the positive sign. Positive sign is this interval and this interval. We can write the solution set between minus 3 and minus 1. You can say, and greater than 3. So the solution set is between minus 3, minus 1 open interval, union greater than 3, 3 to infinity. So it is between minus 3, minus 1, and greater than 3, which is 3 to infinity. So this is how to solve polynomial inequalities. First step is find the critical values. Second step is check the sign of the polynomial and decide which one we choose, the positive or negative, depending on the sign of the inequality.